All right, homework 5.4 builds on what we talked about in 5.3 using binomial probabilities. Remember, for binomial probabilities, you have a fixed number of trials, and the probability of those trials stays constant, okay? And the number of trials is n, the probability that stays constant is p, and this x is the number out of the number of trials, the number you're concerned with. So as we read through this problem, you'll figure out those three variables. So here you have a workers' union, particular university, quite strong. 94% of all workers employed belong to the union. Okay, there's your probability. Recently, the workers went on strike. The TV station planned to enter 5 workers. Okay, that's going to be your number of workers. That's going to be N. What is the probability that exactly 3? Okay, there's your X, exactly 3 workers interviewed are union members. So you could use our formula here. This is the formula that generates your probability for this situation. But we talked about it using your calculator as well, where you would use binom PDF. Since you're looking for exactly 3, type in 5.94 and then 3, and it would pop out your answer. So I'm going to do that real quick. Type that in, 5, comma, 0.94, comma, 3, and I'm coming up with 0.032 with a rounded 3 decimal places, yeah, 0.032. Make sure I type, nope, that is the wrong answer. I didn't think that made sense. I was using binomial CDF, which is important that you don't use. So let me go back and do this again. So I'm going to go down to binomial PDF. Number of trials is 5, probability is 0.94, and the X value is 3. 0.030 when you round it. Okay, that would be the PDF one. Let's look at another one. Again, I used PDF because of the exactly here. Now, this one is, we got 45%, so there's my P. 45% of all babies born in a particular hospital are girls. If 6 babies are born in a hospital are randomly selected, what is the probability that fewer than 2 of them are girls? Fewer than 2, not exactly 2, fewer than 2. So really, what I want to know, what is the probability of getting 1 girl? So the probability of getting 1 girl, or the probability of getting 0 girls, and I need to add those together. So I can do that a couple of different ways. I could use the PDF, binom PDF, for both of these. To give me those 2 probabilities and then just add them together. Or I could use the binom CDF. CDF is cumulative, and it counts down. CD counts down. So if I type in binom CDF with 6 trials, probability of success 45, and I want fewer than 2. So that means I want 1 and 0, 1 on down. So I wouldn't type in 2 here. I would type in 1 because I'm looking at 1 and then the ones below it. So if I go to my calculator, scroll down until I get to binomial CDF, number of trials is 6, 0.45, and 1 for the X value, I should come up with a number like 0.164 4 is what I'm looking at. All right, so fewer than 2, I'm looking at CDF here instead of PDF because it didn't say exactly 2. Now, let's go to one more. A new surgery is successful if the result, so there's our P. The result, if the results of 8 such surgeries are randomly sampled, what is the probability that more than 5, okay, of them are successful? So really, here's what I'm looking for. More than 5, I'm looking for the probability of getting 6, probability of getting 7, or the probability of getting 8 of those surgeries being successful, all right? So I could find each individual probability here using the PDF and add them together. Or I could use CDF, but I gotta be smart about it. Okay, so if I were to, here's what a lot of students do, just so you know. They type in, binom CDF, they type in the 8 trials, probability of success is 0.75, and then they read this problem, they say, okay, more than 5, so they type in a 5. All right, so what that does, though, that gives them the probability of 5, because it counts down, right? It gives them all these probabilities added together. It gives them all of those added together, and that's not what you're wanting, okay? If I added all these probabilities together, that's not what I'm looking for when it says more than 5. What I'm looking for is actually the complement to this, okay? Because I'm looking for 6, 7, and 8. More than 5 would be 6, 7, and 8, okay? These two things are going to equal 1 because this is all these probabilities from 8 on down, 8, 7, 6, 5, 4, 3, 2, 1, 0, all those probabilities are going to equal 0. Since this, if I type that in my calculator, let me do that for me real quick. So that's going to give me 8.75 and 5. This probability right here is 0.321. Okay, so what I'm going to end up doing is saying 1 minus 0.321. That's going to equal 0.679. That's going to be my answer to this problem right here because it's asking for more than 5. Okay, so play around with these, get good at them. Let me help if I can.